We have learned how to combine like terms, and we have learned how to use the distributive property. And today we're going to take what we have learned, combine like terms, and the distributive property, and we're going to build on that, and we're going to learn how to solve one-step equations involving adding and subtracting. But before that, we need to have some vocabulary so we are speaking the same language. Inverse operations is an operation that undoes another. So go ahead and write that down. I'll write it down as well. All right, so I've written an operation that undoes another. I put undoes in quotes, and I think you'll understand why I did that in just a second. So let's look at a couple of examples, because I think once we see examples, that definition will make more sense. So addition undoes subtraction. And just like addition undoes subtraction, subtraction also undoes addition. So I've done an arrow both ways to show that addition undoes subtraction and subtraction undoes addition. Another example, and I think this will be obvious, division undoes multiplication. Just like multiplication undoes division. So there are two examples that we're familiar with that I think helps explain what an inverse operation is. So an inverse operation is an operation that undoes another. We have talked about equivalent expressions. Remember, expressions does not have an equal sign. Equivalent equations is going to be just very similar to equivalent expressions, except that an equation does have an equal sign. So an equivalent equation is an equation that has the same solution. So I'm going to go ahead and write that down. So equivalent equations are equations that have the same solution, or solutions plural, because sometimes an equation has more than one answer. As we begin really going into algebra, one of the things that you have to remember that really in math, but particularly in algebra, everything is fair and equal. And that's one of my favorite things, particularly about algebra. Everything is fair and equal. So that means what you do to one side of the equal sign, you must do to the other. So I'm going to go ahead and write that down. Alright, so in algebra, everything is fair and equal. What you do to one side of the equal sign, you do to the other side. And then I wrote in red, this keeps everything balanced. So when we are talking about algebra, we want to keep everything in balance. Everything needs to balance. One side needs to balance the other side. So when solving an algebraic equation, the goal is to get the variable by itself so that you know what the variable equals. So one of the things that I've done to kind of help this make more sense is I've come up with a little story, and I'm going to read it to you in just a second. Alright, so I'm going to read this paragraph to you and you can follow along. It says, when solving algebraic equations, it is sometimes helpful to think of the equation as an island. One side of the island contains the brothers and the other side contains the sisters. The equal sign keeps the brothers and the sisters separate. In order to keep the brothers and the sisters from fighting or from living in peace, everything must be equal. When you solve for the variable, you are finding what is needed to keep the brothers and the sisters living in peace. So let's go ahead and just look at this example. I'm going to write it a little bit bigger so I have room to do this. So the first thing I'm going to do is I'm going to draw a line so I can separate my brothers from my sisters. Right, and the equal sign is that division. All right, so this is a pretty easy example, one that you probably don't even need to do the algebraic process with, but we're going to do it because we know what the answer is, just to make sure that the algebraic process works. So the whole idea is, how do you get x by itself? So in order to get x by itself, I need to get rid of this plus 7. So how do I do that? Well, this goes back to our inverse operation. How do I undo addition? I undo addition with subtraction. So to get rid of plus 7, I'm going to undo plus with a minus or a negative. I'm going to subtract 7 or minus 7. And what I do to my brothers, I also have to do to my sisters, because in algebra, everything is fair and equal. What you do to one side of the equation, you do to the other. So I know that plus 7 and minus 7, or positive 7 and negative 7, those cancel each other out. Or they go to 0 is really, we say cancel each other out, but what happens is 7 minus 7 is 0. They go to 0, and I am left with x on my brother's side. Then I have 10 minus 7 is 3. So in order to keep the brothers and the sisters living in peace, 3 plus 7 is 10. 10 equals 10. So when I give my brothers that 3, they have what they need to live in peace with the sisters. All right, so I have another example. I have x plus 3 equals 1. And again, I probably don't necessarily need the algebraic process to do this, but we're going to do it using algebra. So the first thing I'm going to do is I'm going to separate my brothers and my sisters. Then the object is to get this x by itself. So in order to get x by itself, I have to get rid of this positive 3 or use an inverse operation to get rid of addition. To get rid of addition, I'm going to subtract 3. What I do to my brothers, I also do to my sisters. So if I subtract 3 from my brothers, I'm going to subtract 3 from my sisters. 3 minus 3, that goes away. I'm left with x. 1 minus 3 is negative 2. So in order for this, my brothers and my sisters, to live in peace, x has to be negative 2. Negative 2 plus 3 is 1. All right, let's look at my next example. I have y minus 9 equals 4. I'm going to separate my brothers and my sisters. And just like before, the object is to get the variable by itself. So I need to get y by itself. I'm subtracting 9. How do I undo subtraction? I undo subtraction with addition. So I'm going to add 9 to my brothers. If I add 9 to my brothers, I have to add 9 to my sisters. Minus 9 plus 9 goes to 0, so my brothers are left with y. 4 plus 9 is 13. So y equals 13. And then I can do 13 minus 9 is 4. 4 is 4. So that is what keeps the brothers and sisters living in peace. All right, so my next example, I have 15 equals u minus 8. There's a couple of ways that I can solve this. I can solve it as it is, or I can put the u on the left-hand side of the equation. It's kind of a personal choice on how you want to solve it. So I'm going to do it this way first because this is how it's written. So I divide my brothers and my sisters, but this time my sisters have the variable, so I'm going to start on that side of the equation with my u. I need to get that by itself, so I have u minus 8. How do I undo subtraction or a negative? I undo subtraction or a negative with plus 8. If I have plus 8 on my sister's side, I have to do plus 8 on my brother's side. Negative 8 plus 8 goes away. So on my sister's side, I'm left with u. Then I have 15 plus 8 is 23. So 15 equals 23 minus 8. That's what is needed to solve that problem. If it bothers me to have the variable on the right-hand side of the equation, I can just rewrite it and solve it the normal way. The only thing that you have to be careful is make sure that the signs to the left match. So here my u is positive, here my u is positive, and minus 8, minus 8. Just make sure that you don't get your signs mixed up. Next example, we have combine like terms. So now we're going to take something that we've learned at the very beginning of this unit and apply it to our algebra. So I have w plus 4 equals 5 plus 10. Before I can solve this, I can simplify it, make it a little bit easier. 5 plus 10, neither one of those have variables, so I can combine like terms, and I get 15. Now I can solve this as if it were a normal one-step equation. My object is to get w by itself, so I have to undo or use an inverse operation with positive 4 or plus 4. To do that, I'm going to subtract 4. If I subtract 4 from my brothers, I'm going to subtract 4 from my sisters. Plus 4 minus 4, that goes to 0. So my brothers are left with w. 15 minus 4 is 11. So my answer for that is w equals 11. Alright, then my next problem, I have 3q plus q equals negative 11 minus 5. So I know, first of all, when there's not a number in front of it, that's the same thing as 1q. Separate my brothers and my sisters. I have 3q plus 1q. That's 4q. And then I have negative 11 minus 5. That's negative 16. This one looks a little different than what we have, what we're working on for today. Let's put a star by this one and see if you can figure out how to solve that one, and we will come back to this one tomorrow. Alright, let's look at our last example, example 5. It says that Carol is out of the office for 8 hours meeting with a client. She spends 0.75 hours driving to the client's office and 1.25 hours driving back from the office. How long was Carol at the office? Okay, so before I even do anything, I'm going to just kind of write out in words what is going on, and then we'll talk through with numbers. Okay, so Carol is out of the office for 8 hours. 8 hours is the total. And then, so driving to plus driving back plus meeting. So how long was Carol at the client's office? That's the meeting. Alright, let's see if we can fill this in with some numbers, make it a little bit easier to solve. Okay, so she's out of the office for a total of 8 hours. Driving to was 0.75. Driving back was 1.25 hours. And then she met with the client, and that's what we're trying to figure out. So I'm just going to call that C for client. Okay, so we have some combined like terms first. So I have 0.75 plus 1.25. If you don't know what that is, get your calculator. But I know that that adds up to 2. So I have 2 plus the meeting. So she spent 2 hours in the car, and then the rest of the time with the client. So I'm going to separate my brothers and my sisters. My variable is on my sister's side, so I need to figure out how to get rid of this 2. And I know that when there's no sign in front of it, it's understood to be positive. So to undo a positive 2, I'm going to subtract 2. If I subtract 2 from my sisters, I subtract 2 from my brothers. This goes away. So the time that she spent with the client was 6 hours. So my answer is 6 hours was spent with the client. All right, if there is anything that does not make sense to you, please come see me in the morning.